Finally, we are ready to do form finding with the force density method. But before we do so, we have to adapt the layout of Stiff. To do so, we just go to the setup sheet, here, setup sheet in our Excel project, and just prepare here the proper layout just by writing force density here in this cell B1 here at the top of this second column. It's alright, force density. Then we go back to the preprocessor sheet and start Stiff just as we are used to do so. And what you see, I've already prepared a square grid of cable elements, so we can directly start. I guess you know how to do that. Just refer to the respective tutorial about generating grids, eventually morphing them. Then we check about the options, so in the theory. So here you see the first modification of the layout, that we now have the full information available about the force density method. So we can give accuracy for the nonlinear iterations in the context of constraints. The whole thing will be nonlinear. We can control the maximum iterations. We can give a penalty factor for the line searches, so these are numerical issues, we come to that later on, and eventually a maximal step length, just to make it a little bit slower the process, or to control the process. Then you can just adopt for a line search. Then regarding nonlinear analysis, we can just control if we just in a restart option, if we just start from scratch or not, or these things. And then we can just also fix the scaling for the deformed geometry, just to make sure that we always see everything in the true scale. And we can just say, okay, during iterations, just show the shape evolution. And here, you have several options: the force density option, the updated reference strategy option, the complete nonlinear option, and a mixed option, just depending on what we are really like to do. So we just go to the force density method. That's the standard, the classical force density approach or method, as you just may know that from closed link grids and chic. Then we have the OS option, which is something which you would like to use if you just go into the evaluation of minimum surfaces, but these are details, we come to that later. Okay, so these are the basic selection of options regarding the force density method. Everything is okay. Then you have to control and make sure that all of the elements, you really are using the force density method. So double click just to check into here. So again, the theory, you see these elements are just chosen or just using the default selection, which is the force density method. Everything is okay. You can also use the hard choice, but that's not necessary. Let's check the default. Eventually, you have to make use of that all of these elements are using that. Then we select all the elements. We go with the right button of the mouse to edit, and then we can just take the choice for all elements simultaneously. Okay. Next, we have to prepare the force density data. That means the specific force densities for the edge cables and the interior cables. Starting with the edge cables, we can do it like this. First of all, select everything and then deselect the interior part, and you see just the edge cables are remaining. Then we go with the cursor to one of the selected edge cables. I press the right mouse button. We receive the drop-down menu for the elements, and then we go to edit. And we can now edit simultaneously the data for all of the selected cables. Force densities are a matter of the loads, pre-stress loads more in some sense. And here down there you see the force density number, which already is given here, 5 for the edge cables. You can modify that, give something else like 6, or what you like. We will just keep it with 5. So the input for the pre-stress, that is not of importance if you have selected the force density options, which we did. Just refer to the previous part of this video, and that's okay. So we just confirm, and now we go to the interior cables. We can select those directly. So I'm going to do it the same. to edit all of them simultaneously. We select all of them, then we go to one of the selected elements, press the right button of the mouse, scroll down to or scroll to edit, and can now directly edit all these selected elements. And with loads, you see we have now chosen a force density of 1 for all of these elements. So we just take it, it's okay. That's all, and we can now directly start to do the analysis. Let's do it, and you see as a result that is our net now in equilibrium, with the larger pre-stresses here, the edge cables, and the smaller pre-stresses in the interior cables. We can just look for the actual pre-stress forces. If we just switch on the normal force evaluation here, the stress result, perhaps if we just go into this edge element, you see we now have a pre-stress force of 12 something. We can change the display to the force density. Also here you see some modifications of the drop-down menu if we just have chosen the force density choice, so that we can trigger to force density, and indeed, this element has the force density of 5, what we just have given. So if you go to the interior element here, so we have a force density of 1, that was exactly our input. We can also look for the length of this element, just again triggering this entry, so no. You see we have a length of 2.2, again triggering the force, the force density and the length. Also here, again the edge cable, we have the length, the force density and the length. You see that for these elements, obviously the local coordinate system has been switched on. We can again switch it off if typically we don't like to have it typically. Okay, that's the possibility about to display the results. I switched that off. And now let's think about what can we do to really find a hyper mesh and on net. So then we go back to create, and all what we have to do is just to raise some of these corner points, this one or that one here, just to trigger the high points. And again, if you go into the analysis, you see after one step, and that's exactly the nice property of the force density method, you just have found this minimal surface-like, HP-like mesh in space. And again, we can just look at the forces here, or whatever, but we just have switched the length here. We just have chosen for the length or for the forces. We just take an element, so then we have here the force of that element, or that one, this one. By that we can just do the complete analysis. The cutting pattern is something what we receive on the back calculation on the project sheets. Perhaps we come to that later. But before we do that, we have furthermore options. Here we are still in the animate mode, and if we now go into the drop-down menu of the background, you see we have possibilities, for instance, to take the shape. To take the shape what we have determined. If we do that, so we take the shape and the force density, and if we go back to the create mode, you see that we have just now taking as the initial geometry of our structure, with the respective force densities, which have been of course the same as before. But if we now start our analysis, you will see that nothing changes, because we already have taken the result as the input to start everything. Okay, let's save and quit. Let's just take a look into the project sheet for the normal force, and there you see here in this column, the respective lengths of the undeformed cable. So the cutting pattern, tuition cutting pattern. If you would like to build these structures, these are exactly the lengths of these cable pieces which you have to take to be from the undeformed shape, that together with the elastic stiffness here gives the final geometry. Okay, So that's in very short terms what has to be done to do form finding with the force density method and Stiff. All other things, yeah, we learn in the seminar, and I'm looking forward to meet you there. Thanks.